Okay, so we're going to work on a little bit of balancing before we go back to predicting. First 5 you'll probably breeze right through, okay? Especially like the first 3, they're especially easy. But 6 and 7, they're going to challenge you a little bit, right? They're not standard reaction types, so some strange things happen. So the tip I will give you for helping you out with these is that you may have to track elements individually, even if they're part of a polyatomic ion. Okay, because in 6 and 7, there are polyatomic ions, but one of them breaks up, okay, and goes into 2 different places. Like what happened in the first reaction in your reactions lab yesterday. Okay, so balancing involves you really having to track things back and forth. All right, so give you guys a bit of time to get going on those, right? And then we'll go through them together, and then we'll work on some more prediction stuff. These are in your digital workbook, by the way, okay, these questions. So in case you're forgetting where that is, okay, the digital workbook is here in worksheet packages and other materials, okay? If you view the instructions there, you'll see them all in there. The chemistry one is the middle one, okay? And then you also have in the course materials part, okay, a thing labeled chemistry worksheet keys. If it's in the digital workbook, the key is in here. Okay, so there's a whole bunch of naming keys, which we used a long time ago, but there's also one for the mole equation stuff, and there's this one here that is keys to all reaction worksheets. So if you're working on one of these, doing some of the questions that we never have time to do in class, all of the answers, come on, just open up. Okay, are in there. Okay, so that's the one we worked on last week. Okay, and then we worked on this one earlier in the week, okay, where we did all the balancing and identified, but we didn't get it all done. There's much more there. This is the one we're working on right now. Okay, so you can see they're all in there. Okay, there's some other ones in here that we didn't even get to. Okay, more reaction prediction, like there's just tons in there. Okay, so there's lots and lots of questions in there for you to use to practice. A couple of other things to remind you before we get back to that. Your lab reports are due next Thursday, so if you're wanting me to look them over, oh, that's what I forgot to do. We got to look over your labs. Okay, we're going to do that right away too. So, now I lost my train of thought. Oh man, getting old sucks. Oh, sorry, your lab report due on Thursday of next week. So if you're wanting a review, come in and see me, okay, next week, and we can look it over. And remember that I don't do that virtually, okay? So don't email me and go, hey, Mr. Coderre, it's like 10:30 at night, and can you please look my lab over? Because I won't do that. You can come and see me, okay, in person on all my help times, and I'm happy to do it then. Plus, I'm old and I'll probably sleep by it. And then your exam is, okay, on the 14th of March, and I will put out a unit exam review package middle of the week next week. That package will include some review activities, okay, and there'll be a key for those, and there'll also be a practice test. Okay, now I will caution you, some people do this. They do the practice test before they do any studying. Do you know what the practice test then tells them? That they need to study. So the thing you should do is study, do all the review stuff, then do the practice test, and then the practice test will tell you, you still need to study these couple of things, as opposed to you need to study everything. All right, does that sort of make sense? So the practice test is a good tool, but use it much later in the studying process. Okay, that'll be next week. All right, let's talk about your lab reports. Okay, ammonium on this side, which is NH4, breaks up. There's one less hydrogen here on this side, kind of like your first reaction in your lab yesterday. Okay, so what I have to do is figure out, where did that extra hydrogen go? Well, the only other place it could possibly be, since hydroxide has already been accounted for here, is here. Okay, so that extra hydrogen is there now. It's become part of water. So now that I'm looking at that, okay, what I've got to look at here is probably I want to balance like the chlorines or the hydroxides first. I'm going to balance the chlorines. Okay, so there's 2 chlorines on that side. If I put a 2 here, that'll balance my chlorines. Okay, it'll give me 2 nitrogens and 8 hydrogens. So I'm going to go over here and make sure I've got my 2 nitrogens. When I do that, it gives me 6 hydrogens. So I've got 6 hydrogens here, but I need to have 8. Where can I get another 2 hydrogens from? right here in the water. Now when I do that, that also fixes my hydroxide problem, because now I got 2 hydroxides on both sides, right? And then everything else is a 1. Okay, number 7 is very similar to that one. How many people have done 7? Okay, some people want now a chance to try 7 now that they've seen how 6 went. Okay, I'll give you guys a couple more minutes and then we'll do 7. How many people have done 3 and 5 in the prediction? Okay, give you guys a couple minutes and we'll look at all of those. Okay, so for number 7, same idea, okay, but this time I've got 2 ammonium ions on the reactant side, okay? So I've got to kind of keep that in mind when I'm tracking where everything went. The hydrogen did the same thing, it went to water, okay? When I've got sodium sulfate over here. So what I'm going to do is I think I'm going to try and balance my sodiums first, okay? It's the biggest number here. I mean, hydrogens, yes, it's a 3, but it splits up. So I'm going to try the sodium first. I'm going to put a 2 here to balance my sodiums. Okay, that's going to give me 2 hydroxides. So I'm going to come here and put 2 hydroxides there. Right? And when I do that, that gives me 2 hydrogens. On this side, how many do I have? 8. Okay, so if I want to balance my hydrogens, I need to put a 2 here. Now I've got 2 times 3 is 6, plus 2 more is 8. That 2 also takes care of this 2. Okay, it gives me 2 nitrogens. There's 1 sulfate on both sides. That looks like it. 1, 2, 2, 2, 1. Okay? It's a tricky balance, but I would say still a fair question on, let's say, like an assignment that you might get next week, okay, where you have to do some balancing. I can ask you to balance a reaction that's not one of our standard 5, okay, because balancing is balancing. I would never ask you to predict this reaction. Okay, that would be unreasonable. But it wouldn't be unreasonable to ask you to balance one like that. Okay? Now, would I make every balancing question as hard as that one? No. But in the end, did following our balancing rules work without really having to think too much about it? I started with sodium on the second one. I started with chlorine on the first one, and I got it all to balance. Okay, let's look at number 3 here. Okay, I got magnesium solid. What does that look like? And I don't mean what does it look like if I saw it. What does it look like if I want to write it? Mg, yeah. Okay, magnesium solid's just Mg. So this is the harder way, right? Because you have more to do. I didn't write out the reactants in formula form for you. Now you have to write out the reactants. Okay, is Mg special?
No.
No, okay. Now it's reacting with nitrogen gas. Is that special?
Yes.
Yes. Okay, and is it important for me to remember that? Really important, or I'm not going to balance the reaction correctly. Okay, so this is where it really comes into play. What kind of reaction am I looking at? Synthesis. Okay, this is going to make then a compound that contains magnesium and nitrogen. I have to write it this way because it's going to be ionic. Magnesium is a metal. Right? What do I have to do with an ionic compound? Swap and drop. Okay, so I got a -3 and a +2, so Mg3 N2. And my nitrogens are already balanced. 3 magnesiums here ought to fix the rest. Okay? Questions on that one? All right. Now, for iron 2 sulfide, okay, so what's the Roman numeral tell me? The charge. All right, so iron with the 2+ charge is with sulfur with the 2- charge. So when I drop and swap that, it's just 1 and 1. So that's okay, FeS. Reacts with oxygen gas. Now, on a quiz or a test, would I give that to you, O2? Or would I expect you to remember it's special? I would expect you to remember it, yeah. Okay, O2. What kind of reaction are we looking at there? Single replacement. Okay, so in the single replacement reaction, this element replaces the part of the ionic compound it's like. So that means it's going to swap out the sulfur. So I'm going to have Fe with O and sulfur. What do I have to check? Special elements. I have the specialist of the specials. And what else?
Swap and drop.
Swap and drop. That compound's okay because it's a 2 and a -2. The iron's charge doesn't change in the reaction. I knew it was a +2 over here, so it's a +2 on the other side. Okay, now looking at that, I got some balancing to do because I got a big old 8 on one side. Okay, so I got to put an 8 here to balance the sulfurs. Going to need an 8 here to balance the irons, and a 4 here to balance the oxygens. Okay, so a bit of work to do on a question like that. Okay, I would like you guys to also try 6, 11, and 12. All right, so for number 6, we got molybdenum, which is MO, okay, and it has a crazy charge of +6. Okay, is reacting with, is with sulfur. It's molybdenum sulfide. This is a -2. When I drop and swap, what numbers do I get? 1 and 3. Okay, because I have to reduce. I don't leave it as 2 and 6. Okay, and it's reacting with oxygen gas, which is special, O2. What kind of reaction are we looking at? Single replacement. Oxygen's going to swap out the sulfur, so molybdenum is going to end up with oxygen. Sulfur is going to wind up alone. Okay, sulfur is special, so we got to put an 8 on there. This is a -2, this is a +6, so just like on the other side, okay, we're going to reduce that down to 1 and 3. Okay, so we got Mu3 plus S8. Okay. Now we got to balance the whole thing, and I am feeling some big numbers here. Because on one side I've got 8 sulfurs, and on the other side I have 3 sulfurs. What's the lowest common multiple? 24. Okay, it's the first number that they will both go into. All right, so I need to put an 8 here. 8 times 3 is 24. I need to put a 3 here. 3 times 8 is 24. Okay, now I've got 8 molybdenum on this side, so I need to put an 8 here. That's going to give me 24 oxygens, so I need to put a 12 in front of the oxygens, and that's the lowest set of numbers I can get for that. Okay, sometimes that happens. All right, number 11, aluminum reacts with iodine. Okay, Al, special or not? Not. Reacts with iodine, special or not? Special. Okay, what kind of reaction is that? Synthesis. Okay, so aluminum is a +3. Iodine is a -1. Al-I3 would be what we're looking at there. And then I've got to balance it. 3 is the biggest number. It's 2 over here, so 3 and 2 and 2 should make that one work. Okay, and then on number 12, we got silver nitrate. Okay, reacts with copper 2 chloride. So AgNO3, that's a -1, that's a +1. Reacts with copper 2 chloride. Okay, +2 -1, so CuCl2. What kind of reaction is that? Double replacement. Swap the metals. You got copper 2 nitrate and silver chloride. Okay, you got to do some balancing. A 2 there and a 2 there ought to do it. Okay, so the only way to get good at this is to practice. So we'll be doing a little bit more practice, and I'm going to give you some harder ones, okay, next week. And then we'll probably be doing our assignment on this early in the week next week as well. Okay, we'll get an entire class period to work on that, but it'll be 30 questions of various types. Okay. All right. Good job today, guys. Have a good weekend, but not too good.